Question 4b, part 2. Where is it? During processing, the copper carbonate is reacted with sulfuric acid to make copper sulfate. Calculate the relative molecular mass of copper sulfate. So, use your periodic table, and you find copper, and it's about 63.5. Sulfur is 32, and then oxygen, and we've got 4 of them, 4 lots of 16. So then that's 63.5 plus 32 plus 64, and that equals 159.5. Nice easy point there. Next question, 4b part 3. Calculate the mass of copper carbonate required to give 3 tons of copper sulfate. Assume 100% yield. Or what that means, that 100% yield, is that all of the copper carbonate gets converted into copper sulfate, water and carbon dioxide. So it's asking you to work out how much of the copper carbonate you need, so mass of this, when you're told that you need to make 3 tons of this here. So first thing you need to do is to work it, or convert it into moles. Now we're not going to convert from tons into grams, although you could do. We're going to keep it simple, and we're going to give our final answer in tons, so we can keep it in tons at this point here. So we convert this into moles, so we divide this by 159.5, and what we get is 0.01881 moles, and we see that this stoichiometry is that for every 1 mole of this we need to react 1 mole of this, so therefore this number stays the same. And when we're going downward we divide, but when we're going up we multiply. And the MR of CuCO3 is 123.5. So we multiply these two numbers together and we will come out with the mass in tons of copper carbonate required. So the final answer is 2.3 tons of copper carbonate required. Now you could have done this again by converting from tons into kilograms, so times by 1,000, and then from kilograms into grams and times by another 1,000, then divide by 159.5, which will give you a much bigger number. That would be this number times 10 to the 6. That number would then be repeated here, multiplied by the MR, and again you would come out with a value, but this time instead of being in tons it would be in grams.